Hello, this is Mr. Best. Welcome to Chapter 7, Homework Questions 106 to 111. Question 106. Find the equation of the exponential function that passes through the points 2, 48 and 5, 750. Now, there's really two ways that we had looked at this in class. One was by setting up a system and solving algebraically, and then the second one was using our table and being able to find the multiplier that way, and then working backwards to find the initial value. So I'll show you the table method, and then if I have time, maybe show the system, or at least write it so you can see where it came from. First, let's go ahead and just set up a table. So 0, 1, 2, that point is at 48, 3, 4, 5, that one is at 750. So by using the table, what we were asking ourselves is 48 times what value of b would give us the y when x is 3, and then multiply by b to find y when x is 4, and then multiply by b would give us 750 when x is 5. And so what we kind of did was we would set up an equation. 48 times b times b times b, or b to the third, should equal 750 if this is an exponential function. And so we'll take 750 and divide it by 48, and we get a value of 15.625. And then we were able to work backwards and take the cube root of 15.625. And when we did that, we got a value of 2.5. So b was equal to 2.5. And once again, we worked backwards by taking the cube root of both sides. And so now we have the multiplier, and now we can work our way backwards to find the initial value. So we would take actually 48 and divide it by 2.5, and that would give us 19.2. And then one more time to work backwards, 19.2 and divided by 2.5, and that would give us 7.68. So that was enough to be able to write the equation. Y is equal to the initial value of 7.68 times the multiplier of 2.5 raised to the x power. So that's the way to do it, by using a table. I'm going to pause the video, but I'll show you algebraically what that would look like also by using systems. And so there you can see how I solved it using systems of equations, using the 2 points to plug in the information for x and y, and then solving for a, and then substituting that back into the other equation. So those are kind of both the methods we looked at. Question 107. After noon, the number of people in Malwart grows steadily until 6 p.m. If the equation y equals 228 plus 58x represents the number of people in the store x hours after noon, how many people were in the store at noon? So if we're going to have how many people were at the store at noon, then x is the hours after noon, then the equation y equals, and I'm going to write it in slope-intercept form with the 58x plus the 228. Then question A, how many people were in the store at noon? There were 228 people. B, at what rate is the number of shoppers growing? Well, the rate of change is 58. So the rate that the number of shoppers is growing is 58 shoppers per hour. And then for part C, when were there 402 shoppers in the store? Well, Y represents the number of shoppers in the store after noon, so that'll be 402 is equal to 58x plus 228, and then we can solve this equation for the time, which is once again, x represents the hours after noon. So we get 174 is equal to 58x. If we take 174 divided by 58, we get x equals 3. So when were there 402 shoppers in the store? Let's not just say 3. What does it mean? It's the number of hours after 12 o'clock or afternoon. So then we will have 402 shoppers in the store at 3 o'clock, but make sure we write p.m. also. And I think that's it. Question 108. Wade and Dwayne are working together, writing an equation for the sequence 12, 36, 108, 324. Wade wrote T of n is equal to 4 times 3 raised to the n, and Dwayne wrote T of n is equal to 12 times 3 raised to the n minus 1. Make a table for the first 4 terms of each of their sequences. What do you notice? So I went ahead and made a table for both of them, and you can see that the tables are exactly the same. So that's part A. What do we notice? We notice that the sequences are the same. And then for part B, how do you think Dwayne explained his method of writing the equation to Wade? And there's a couple different things. You obviously you could write here. We're just speculating what Dwayne would say, but could say something about that the 12 represents the first term in the sequence, so he knows he needs to multiply by a form of 1, and the only way you can multiply 12 by a form of 1 when you're using exponents is to raise it to the 0 power. So that's why he had to use the n minus 1, so that when you plugged in 1 minus 1 would give you 0. So that's an option, and there's other things that he could write or explain as well. Part C, for the sequence 10.3, 11.5, 12.7, Wade wrote T of n equals 9.1 plus 1.2n, where Dwayne wrote T of n equals 10.3 plus 1.2 times n minus 1. Make a table for the first 4 terms of each of their sequences. Are both forms of the equation correct? So let's go ahead and do the same thing we did for part A for part C, but a different sequence. And so once again, you can see that both forms of the equation are correct. Once again, Wade uses the initial value 9.1 when n is 0, where Dwayne is going to use the first term 10.3, and then to add 0 to that, he has to use the n minus 1 to get that 0. So that's part C. And then part D, Dwayne calls his equation the first term form. Why do you think he calls them first term form? Why does Dwayne subtract 1 in both situations? So kind of just talked about this as to why he might call it the first term form is actually Dwayne is using, if you go back and look, he is using the first term in the sequence. That one was 10.3, and then the other one was the 12. But to do that, he has to subtract 1, so that he is either, in the first case, multiplying by 1, or in the second case, adding 0. So because the coefficient is the first term of the sequence instead of the 0 term, Dwayne subtracts 1 because his equation starts 1 term later in the sequence. So he needs to multiply or add in 1 less time. So once again, you could write a couple different things down there as to what he's thinking, but that kind of gives you the general idea. Question 109. Find the dimensions of the generic rectangle shown at the right and write its area as a sum and a product. So you have your generic rectangle to the right. We're trying to figure out what the lengths of the rectangle are. So, if you're looking at, let's just look at these two, 9x squared and negative 6x. So what goes into both of them? We could say 3x. And then, if that's the case, 3x times what right here is going to give you 9x squared. That'd have to be another 3x. So 3x times 3x, 9x squared. 3x times what is going to give you negative 6x. That would have to be a negative 2x. Or a negative 2, not the x. So negative 2 times 3x is negative 6x. And then to get this one, we could do it a couple different ways, but to get 4... negative 2 times what gives you 4? That would have to be a negative 2. So does that work out with all the sides? So to get this one, negative 2 times 3 is negative 6x. This one, 3x times 3x is 9x squared. To get this one, it would be negative 2 times 3x, which is negative 6x. And then to get the 4, it's negative 2 times negative 2, so it's 4. So that looks like that is correct. So we want to write it as an area of its sum and product. So the sum would be 9x squared and then you have plus 6x, or plus negative 6x plus negative 6x, which would be negative 12x, plus 4, and then the product would be 3x minus 2 times 3x minus 2. And we could have also written that as 3x minus 2 squared if we wanted to. And so that actually represents not just a rectangle, but a square in this case because the side lengths are the same. Question 110. Chris got a summer job at an environmental science lab. He was using a microscope to measure the length of a particular organelle in tree sap cells and the diameter of the cell itself. Chris collected the following data. A is a micrometer of 1/1,000,000th of a meter. So you got your length of the organelle and the diameter of the cell. Part A, what would you include in a mini report that fully describes all aspects of a linear association? Make as detailed a list as you can. So before I created the video, I should include this in here, but I got a snapshot of it, and you can see the answer to question 110 part A. I didn't want to have to type all that out. So the answer key says you want to create a scatter plot, which you can see over here to the right. We got a scatter plot. Compute and draw the least squared regression line. We need to verify the linearity with a residual plot, so you can see the residual plot below. Describe the form, direction, strength, and possible outliers. Draw upper and lower bounds to the model used for prediction. So those are just some things that we could, definitely include in our list as we're going through this. And then B is, fully describe all aspects of the linear association in context, including the appropriate graphs. So you see the appropriate graphs are on here already. So we have the graphs for part B, the scatter plot and the residual plot. And, to go through and do that, you need a graphing calculator. And then once again, you can see on the answer that the least squared regression line is y equals 49.50 minus 1.60x. It says the linear model is appropriate because the residual plot shows no apparent pattern. So you can see in the residual plot here that the points are scattered. So linear is a good model. The slope is negative 1.60, meaning that an increase of 1, and that represents the micrometer or 1/1,000,000th of a meter. And the length of the organelle is expected to decrease the diameter of the cell by 1.6 micrometer. So you can read the rest of it and go through and explain everything, but that's what it's looking for. It's looking for that detailed description of what the scatter plot is telling us, what the residual plot is telling us. Make sure you're including the 4 things that we've talked about, which is, what's the graph look like? Describe the form or the direction, the strength, and then are there any possible outliers? Question 111. This problem is a checkpoint for solving linear systems of equations. It will be referred to as checkpoint 7b. Solve each system of equations. So in part A, it's set up for substitution. 3x plus 11 is going to get substituted in for the y value into the second equation. And then we will be able to solve for x by combining our like terms, subtracting the 11 to the other side to get negative 8, divide by 4, and x equals negative 2. Then you can plug that back into the first equation to solve for 11, or to solve for y. Negative 6 plus 11 is 5. So our solution is x equals negative 2, 5. Let's move on to B. B is also set up for substitution. So x minus, though, in this case, and make sure you put that in parentheses, 2x plus 3 is equal to negative 4. We do need to distribute the negative sign. Combine our like terms, add 3 to the other side, divide by negative 1, so x is equal to 1. Take that, plug it back into the equation. 2 times 1 plus 3 is 5, so 1, 5 would be the solution for B. On C, it looks like it is set up for elimination, so I'm going to leave it in that form. I'm going to take the bottom equation and multiply by just a -1. That will help me eliminate my x values. So x plus 2y equals 16, then negative x minus y equals -2. So if I add these up, my x's are eliminated. I get y equals 14, and then I can plug that back into one of the two equations. I'm going to plug it back into the first one. We get x plus 28 equals 16. Subtract 28. X is equal to -12. So -12 comma 14 would be the solution. And the last one, D. And D once again is set up for elimination. Now this one, your x's and your y's, you're going to have to multiply both equations by something. So 2 and 3's common multiple would be 6, and 3 and 4 would be 12. So I'm going to multiply the top by 3 and the bottom by -2, and that will get my x's to be opposite. So let's see what we get. We get 6x plus 9y equals 30. And then -6x plus 8y equals +4. So you can see the x's cancel. 17y is equal to 34 divided by 17. Y equals 2. We'll plug that back into the first equation. And it looks like we get 6x, or 2x plus 6 equals 10. Subtract the 6, divide by 2. X is equal to 2, and it looks like y is equal to 2 also. So we have the ordered pair 2, 2. And that's how you solve a system of equations. First two, A and B, are set up for substitution, and C and D are set up for elimination. And remember, if the problems are not set up this way, then you have to set them up so that you can solve using one of those two methods.